I really love the wild world. It really makes me happy and intrigued and curious to know how things work. I get excited about understanding new things about the ocean. That's what it's about for me. I think living true to your passions and your beliefs is really important. My name's Lisa Beal. I'm a professor of ocean sciences here at the Rosenstiel School. I'm specialized in observing western boundary currents, so observing the large-scale ocean circulation and how the ocean interacts with the atmosphere and its role in climate. What's behind is the temperature. What I'm trying to do is add some more information that we can give to people in the city so that their expectations of when there's going to be a flooding event, for example, might be a little more accurate. The ocean has weather systems and currents that are analogous to the atmosphere. What happens is then you get this balance between the pressure gradient, the high and the low, and the spin of the Earth. And that balance is called geostrophy, and that moves water. So there's a sea surface slope, there's a high, there's a low, and the water is moving across it. There's a huge change of sea level across the Gulf Stream, about 1 meter, between us here in Miami and the islands in the Bahamas. So their sea level is 1 meter higher than it is here. But what that means is, of course, that if the pressure gradient changes, so that sea surface slope changes, then the current changes. It becomes weaker or stronger. So that is related with sea level in Miami. What we want to measure is to get a handle on all this variability going out there in the ocean. If we know something about what's going on out there and how it affects the coastal sea level, then maybe we can understand better when we might expect some seriously catastrophic sunny day flooding events in Miami. Research cruise is the way that oceanographers collect data. So it's like a field experiment, but our field is the ocean. Yeah. The goal of this research cruise is go out into the Florida current and measure how that current is changing over time and relate those things to the way that the sea surface changes across the straits. It's the most intense and warmest part. As a result, it's carrying a lot of heat away from the equators towards the poles. It's an important part of the climate system. The Walton Smith is actually quite a small research vessel, and she has 7 crew, and then we'll be a group of about 9 or 10 scientists. Right from the word go, we're all working together to get the science done safely. So there are a lot of moving parts, right? We have these enormous buoys and anchors and so on, so we draw out a deck plan, how everything's going to fit, and then of course we have to get all the instrumentation that we're going to bring with us, we have to get that ready in the lab. Is this one of the ones we're going to have a current meter on? If we want to be able to measure how the ocean's changing over time, we've really got to put instruments that stay out there. In this instance, we'll be putting these moorings down, and they are called inverted echo sounders. They basically sit at the bottom of the water column on the seabed. We have 9, and so we're going to put them every 10 kilometers, because it's about 90 or 100 kilometers wide, the Florida Straits at its narrowest point. And they send out an acoustic pulse that bounces from the sea surface, and then they listen to that acoustic pulse coming back again, so it's called a round-trip travel time. Because we know that the speed of sound in water varies with the properties in the water, particularly the heat content, then that round-trip travel time is going to change. It'll also change depending on the strength of the current, because that's related to the temperature and salinity of the current. We also measure pressure, so that tells us the mass of water above the instrument. With those two things together, we can even derive how the water's moving. The shallowest one is 150 meters, so it'll be just after the shelf break, and the deepest one is about 800 meters. That's the deepest part of the Florida Straits. In this case, we're going to leave them for almost 2 years. And then we'll come back and pick them up again by releasing them from their anchors, and they'll float up to the surface. And we have to physically collect those instruments back again to get the data off them. To try to capture some of that interannual variability, we're going to be out there collecting the data for 5 years in total. So we've got 3 deployments of 20 months each.
5 and 2 meter J.
You design the mooring, you want it to be upright, and you design it to be a certain length and to have all your instrumentation at particular parts of the water column, because out there in the Gulf Stream, there's water that's come from the South Atlantic, water that's come through the Caribbean, water that's come from the subpolar gyre. All these different water masses arrange themselves in terms of their density. Some waters are denser than others, with the lightest waters on the top. So it's kind of like a layer cake. Miami is like the #1 city worldwide at risk from sea level rise. I'm really looking forward actually to doing something that's so locally relevant. It'll be exciting to start working more closely with other stakeholders in Miami that are working on these really important issues. The ocean is really the weak link that we have as humans right now in terms of knowing what we're facing with climate change. We have a lot to lose here in Miami.